For the Topic 5 challenge, the goal is to make a flashlight that maximizes brightness using limited materials. 2 bulbs must be lit. The 2 possible ways to approach this is either to make a series circuit or a parallel circuit. The series circuit is the one on the left. This has both light bulbs on one wire, meaning the current has to travel through both of them before completing the circuit. The parallel circuit is on the right. This design has multiple branches in the circuit, allowing the current to travel through one light bulb at a time. Of the 2 possible designs, I decided to use the parallel circuit design because it would fulfill the goal of making the brightest flashlight. As seen in the Circuit Builder simulation, the parallel circuit has a higher current and voltage used per bulb. This means that there would be more power and brightness in this design compared to the other one.
Ha 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 ha.
The parallel circuit has 2 branches, with 1 light bulb on each branch. This means that each bulb can use the total voltage, unlike the series circuit, which has to divide it up. In this case, the total voltage would be 3 volts because each battery has about 1.5 volts stored. Each light bulb also had a resistance of 25 ohms. In order to find the current on each branch, all we need to do is use Ohm's law. And since we know the voltage and the resistance, we can figure out the current in the situation. In this case, the current would be 0.12 amps for each branch and has a total of 0.24 amps. This means that the total power in this circuit would be 0.72 watts. Because the parallel circuit has more power, it allows the light bulbs to use more energy and thus making them brighter. The only disadvantage of a parallel circuit would be that a parallel circuit uses more voltage at a time, which drains the battery at a faster rate. Parallel circuits are the brighter option of the 2 possible circuits. The series circuit puts both light bulbs on the same branch, meaning the total voltage of the circuit must be evenly divided amongst them. As I said before, the total voltage in this situation would be 3 volts. Since this is a series circuit, the current is constant throughout the whole circuit. In a series circuit, we also have to add up all the resistances to find the total resistance. Knowing these, we can find the current, which would be 0.06 amps. There is less voltage used per light bulb in the series circuit. When one light bulb fails to light in the circuit, the other is also unable to light. The series circuit would only have a power of 0.18 watts. The series circuit may have less brightness than the parallel circuit, but it uses the battery up at a slower rate.